Hello viewers, I am Kausalya. Today we are going to solve example 15. And the problem is prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 which is equal to 1 by secant theta minus tan theta, and here they are specifically giving use this identity. Okay, secant square theta is equal to 1 plus tan square theta. Right. So here the thing is, now we are going to take our LHS and finally we are going to prove that this term is equal to this term. Right. So here the thing is, take your LHS. Right. After taking the LHS, we are dividing both the numerator and denominator by cos theta. Right. So when you divide it by both the numerator and denominator, you see we are having an expression like this. And again, the next step is I am going to split this denominator for each and every term. Right. So sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta divided by again sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. Right. So here the next thing is sin by cos is tan and cos by cos becomes 1 and 1 by cos becomes secant. Similarly, sin by cos is tan, cos by cos is 1 and 1 by cos is secant. Right. So just we are having an expression like this. The next thing is I am arranging it. That's it. Right. So tan theta plus secant theta minus 1. Right. Similarly, tan theta minus secant theta plus 1. Right. So after arriving with this step, the next thing is we are going to multiply both the numerator and denominator by tan theta minus secant theta. Right. We are doing all these things just to arrive at the final answer. Right. So here we are multiplying both the numerator and denominator. Right. By tan theta minus secant theta. So now I am going to multiply the terms in the numerator. Right. I am going to keep this denominator term as such. Right. So when I multiply, what happens, you see, this term gets multiplied by this term. So tan theta plus secant theta multiplied by tan theta minus secant theta. Here minus and 1 gets multiplied by tan theta minus secant theta. So minus tan theta, this minus here and this tan theta minus secant theta term as such. Right. Now the next thing is, you see, this is of the form a plus b into a minus b. So here we can write it as a square minus b square. So in the place of a I am having tan theta, in the place of b I am having secant theta. Therefore tan square theta minus secant square theta, and this minus tan theta minus secant theta as such, and again we are writing the denominator term as such. Okay, we are not touching the denominator. Now tan square theta minus secant square theta becomes minus 1. Why? Because our identity is, you see, this is our identity. Right. Secant square theta minus tan square theta is equal to 1. But here what we are having? We are having tan square theta minus secant square theta. This is just reversed. Therefore, when it is reversed, then automatically this is equal to minus 1. Again, if you have doubt, multiply both sides by minus 1. Right. So when it is multiplied by minus 1, what happens here? Minus 1 into secant square theta becomes minus secant square theta, and this minus 1 into minus tan square theta becomes plus tan square theta, and 1 into minus 1 becomes minus 1. Right. So this is what we are having here, right? Plus tan square theta minus secant square theta. Therefore here this is equal to minus 1. So just replace this term by minus 1 and I am moving this minus within the bracket. So this plus tan theta, that is plus into minus, becomes minus tan theta, and again minus into minus becomes plus secant theta. Right. And again we are writing the denominator term as such. Right. Now the next thing is, you see, here from this expression, so here you see now the numerator part is over. Right. So in the next step we are writing the numerator as such, and here I am again rewriting this equation, that is tan theta minus secant theta is written as minus of secant theta minus tan theta, right? These two are same. Just you check. Minus into plus secant theta becomes minus secant theta, and minus into minus tan theta becomes plus tan theta, right? We are reframing just to arrive at the final expression, right? So here it is minus and we have framed. Now what happens here? Again I am multiplying this expression with this minus sign. Right. So what happens? Minus into plus tan theta becomes minus tan theta. Minus into minus secant theta becomes plus secant theta. And again this minus into plus 1 becomes minus 1. Right. So now what happens? When you check, you see this numerator term and this denominator term. Right. Sorry, after multiplying, not this term. You see, I have multiplied this minus with this term, right? So minus into tan theta, minus into minus secant theta, plus secant theta, and minus into plus 1 becomes minus 1. Now both this, you see, minus tan theta, plus secant theta, minus 1. Right, now these two terms cancels each other, and finally we are having 1 by secant theta minus tan theta. Okay, this is the element which is present in your RHS. Right, now we are going to solve the same type of problem which is in your exercise. So you see, we are having the same type of problem in exercise 8.4, and this is the problem that comes under the problem, fifth problem, and it is a fifth part. Right, under fifth problem, this is a fifth part, and this is the sum. Cos A minus sin A plus 1 divided by cos A plus sin A minus 1, which is equal to cosecant A plus cot A. Using the identity cosecant square A equal to 1 plus cot square A. Right, here again you have to prove that. Right, so the same thing, that's the reason why I am solving these two problems at a stretch. So consider your LHS. Right, so in this case we are going to divide both the numerator and denominator by sin A. So in the previous problem we are dividing it by cos A. Again I will tell you a simple trick. You see, if the first term is cos A, you just divide it by sin A. Right, in the previous problem the first term is sin A, therefore we are dividing it by cos A. Right, just keep it in mind. So here we are dividing both the numerator and denominator by sin A. So the next step is you have to divide, that is you have to split these terms and write, right? Therefore cos A by sin A minus sin A by sin A plus 1 by sin A. Similarly for the numerator, cos A by sin A plus sin A by sin A minus 1 by sin A. Right, now the next thing is cos by sin is cot, and sin A cancels each other, that becomes 1, and 1 by sin A is cosecant A. Similarly, cos by sin becomes cot, sin cancels each other, therefore 1, and 1 by sin A becomes cosecant A. Right. So the next step is I am just rearranging the terms. So cot A plus cosecant A minus 1. Here cot A minus cosecant A plus 1. Right. So here in this case you see, in the place of 1, right, we are replacing this 1 by cosecant square theta minus cot square theta, because you see here we are having terms cot and cosecant, right? So there we are selecting an identity in terms of cot and cosecant. So here this 1 is replaced by cosecant square theta minus cot square theta. In addition, they had mentioned in the problem, you see, that is using this identity, right? So from this identity, just now we have framed cosecant square A minus cot square A is equal to 1. So in the place of 1, just write cosecant square. Here since we are having A, cosecant square A minus cot square A. Right. So this is of the format A square minus B square. So in the next step, we are splitting and writing it as A plus B into A minus B. Right. So after writing this, you see here, we are having cot A plus cosecant A. Similarly, cot A plus cosecant A. Right, so in between we are having a minus. Okay, just be aware of that. So we are having two terms. Okay, this is one term and this is your another term. So in these two terms, I am taking this cot A plus cosecant A commonly outside because they are in addition, right? Here 2 plus 3, here 3 plus 2. Both holds the same meaning. So when you take this term outside, the remaining terms will be, in the place of this, we will be having 1 minus, and this term we have taken outside, and remaining we will be having this term. Right, when this minus is moved inside, what happens? Minus into plus cosecant A becomes minus cosecant A, and minus into minus cot A becomes plus cot A. Right, divided by, and this denominator term as such. Now what happens? You see, both these two terms cancels each other. You see, 1, it is plus 1, and here plus 1. Minus cosecant A minus cosecant A. Plus cot A, here it is plus cot A. So these two terms cancels each other, and finally we are having cot A plus cosecant A, okay, which is equal to your RHS. Okay, this is the thing what you need to actually prove. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.